Alright, what's up guys? I'm Justin. I'm the treasurer of IEEE,
And I'm Kevin, the secretary of IEEE.
and today we're gonna give you guys a little insight on breadboarding. So if you're taking 201, this is a pretty helpful workshop for you because we'll go over the basics of breadboarding, a little bit of De Morgan's theorem, which you'll eventually learn when you're doing Boolean algebra, and then we're gonna give you guys like a little demo on how to properly breadboard
And plus,
on
this
a
demo is basically going to be like your first lab as well. So it's going to be coming in clutch.
yeah. Alrighty, so here are some of the topics. And Kevin.
So first thing we got is breadboard basics. So we're going to start off with the layout. As you can see on the right side of the picture, you got these columns and these rows. So I'm going to use my pointer. Okay. So as you can see, the far left, you have a plus and a negative. So what that means is that's how you connect it to the power source. So you connect the positive terminal of the power source to that column, just any hole, and then once you connect that hole, the whole column will be lighted up and good to go. And then as you can see in the middle columns, it goes, instead of going up and down, up and down, it's going left and right. So now you'll see that these horizontal rows, those are the ones that are connected with one another. So once you insert any sort of connection to one of those holes in that row, then the whole row is going to be lit up. Then you'll see in the very middle, it's got a divider. So that divider, just you have a disconnect. So it doesn't go from A to J. It's going to go from A to E, then it's going to cut off, and then F to J. And then on the right side, it's going to be the same thing, just to power your breadboard. And the limitations. So it is not permanent. What that means is wires can easily become disconnected. So especially in 201, you're going to find that it's going to get really annoying because you're going to have to troubleshoot a lot. You're going to have to figure out, so just because you have the circuit and it's good to go, once you actually create the circuit, there could be a lot of physical problems that come along the way. So sometimes the wires, they're not conducting electricity as it should be, and you can test that with a multimeter. Maybe the logic gate itself is messed up. It's not good, or even your power source. It could be out of battery. So just check for those physical problems. And then not suitable for high frequency. So just keep in mind that when using the breadboard, it's 20 picofarads of capacitance per connection. And so the higher the frequency, the more capacitance affects your circuit. The good thing with 201 is you don't have to worry about that because you won't be dealing with frequency. It's just going to be pretty simple and direct.
All right. So now we're gonna just go a little bit beyond breadboarding. So we're gonna talk about how you get from a breadboarding project to a final product. So you first start off by simulating your circuit. So let's say we want to have an LED turn on when we use one of our IC chips. So then you'll try and simulate that circuit on a circuit simulator such as Spice. And once that circuit shows that it functions on the simulator, you're gonna want to put on a breadboard. So you're gonna want to get all your components together that you're gonna need and stick them on that breadboard. And if that works, then you're gonna try and create the final product using a PCB, which looks like this. And a PCB stands for a prototype circuit board. And then from your prototype circuit board, you're gonna move on to your final product. So we're gonna talk about a little bit about data sheets because they're very helpful in 201. So when you guys look at your IC chips, you're gonna see all these little pins off to the side of it, these little metal parts, and you're gonna see 8 on each side. So you're gonna have a total of 16. So you're probably wondering, how do I know which side is the correct side? You know, like, am I holding it correctly or am I holding it all upside down or whatever? So what you want to do is look for a little notch at the end of your IC chip, and that'll tell you you're holding it in the correct orientation. So from there, we can confirm that we have 1 through 8 on the bottom going from left to right. And on the top, we'll have 9 through 16 going from right to left. So if we look at a regular data sheet, we'll see that, all right, oops, that pin 1 corresponds to the first input of our AND gate, and pin 2 connects to our second input of our AND gate, and pin 3 connects to our output. So 1, 2 are our inputs, 3 is our output, and same goes for 4 and 5 being inputs, 6 being an output, and 7 is our grounding.
I'm going to interrupt you really quick, Justin. Dakota says he's in the waiting room.
Oh, really? Man, hold on.
Whoever's host has to do that. So Kevin. Oh, wait, no, Justin's host.
Yeah, give me 1 second. How do I stop sharing this thing? Oh, stop sharing. Security.
I believe you can turn it off so you don't have to have a waiting room.
The waiting room isn't enabled. Oh, he's in here.
Yeah, I'm here.
Oh, there we go.
I just snuck in right now.
Damn, Dakota, yo, chill, bro.
What's up, bro?
How you guys doing?
Good and you?
Some technical difficulties or what?
Nah.
Yeah, somebody in the waiting room, Dakota. No, I'm just playing.
Alright.
I don't know. The link wasn't working.
Okay, okay. Well, we got you in here now, man. That's all that matters.
Alright, so pin 7 is correlated to our grounding part of the chip. So you're gonna want to stick a wire in this portion on pin 8. Oh no, pin 7, my bad. And you're gonna want to connect that to the negative terminal. While on pin 14, notice how it says VCC in small print? That's gonna correlate to your positive terminal. So you're gonna put a wire from pin 14 to the positive terminal, and boom, you'll be able to use your chip. And yeah, that's pretty much all you guys need to know about data sheets. You just gotta read them carefully and look out for the pin inputs and outputs that you need to put in correctly.
At the same time, at the end when we do our demo, when we actually do our practical application, you'll get a better picture of exactly what he's talking about for the data sheet because we're going to go through it together.
Yeah, and if you guys have your breadboard packages, I would recommend that you guys follow along when we do the demo, so you guys get a better feel for it.
So now we're going to go over De Morgan's theorem. I'm actually going to bust out a scratch paper because this can get a bit confusing. So as you can see with De Morgan's theorem, it's showing the first section AB and it translates to AB naught. So what happens with De Morgan's theorem is if you get an equation, yeah, I'm just going to do it step by step. I'm going to bust out a piece of paper for you guys. So can you guys see my my video or no?
Oh, let me stop sharing. It's upside down, bro.
Upside down. All right. You guys good?
Yeah.
Yeah, that's perfect.
All right. So in class, you guys can get a problem. So if it says apply De Morgan's theorem on this problem right here, you got AB. So all that means is what you're gonna do is you're just gonna knot the whole thing. When you knot the whole thing, you put this bar over. Then after that's the first step. Then after that, the next step is you're gonna break up these bars. So you're gonna get A naught. And since these are multiplied with each other, you're gonna reverse the sign. So it's gonna be plus and then B naught. And that right there is De Morgan's theorem. And then the other one was A plus B. So if they ask you to apply De Morgan's theorem to A plus B, first step is just putting this bar on the top. Then the second step is breaking these bars and reversing the sign. And then, Justin, if you go back to the slide. So what we just covered right there is basically what happened on the very top, as you guys can see. So AB, then we ended up with A naught plus B naught. A plus B, you end up with A naught times B naught. So the next thing we're gonna go over is in a schematic, you can remember what this thing on the bottom is it's saying that a negative OR is equivalent to NAND. So there's a concept that we can go over, which is basically, it's called pushing the bubbles through. So as you can see, the bubbles in a negative OR, this is considered a negative OR because it's an OR gate. So this shape, kind of like the pointed tip of spear at the very top, that's going to be an OR gate. And then those bubbles, that means that the inputs are knotted. So that's why we get this negative OR. So this negative OR is equivalent to a NAND. So when you think about how it's equivalent to each other, just remember about pushing the bubble through. So basically, whenever you push the bubbles from the inputs through, all you're gonna do is just switch the gate. So if you have an OR, it turns to an AND. If you have an AND, it turns to an OR. So in our class, we would just say, push the bubbles and switch the gates. So as you can see in the bottom, you have a negative AND. All we did was just push the bubbles to the tip, and we just changed the gate from an AND to an OR. So now it's an OR. So that's how you find equivalent gates. And the reason why that's important is because as you progress through 201, they're gonna, basically the training rules are gonna be AND and OR gates because they're simple. But that's not realistic because it's gonna be limited to the type of circuits that you create. So it's gonna get towards the end of the semester where the professor's only gonna allow you to use NAND gates. So this is why when we create these circuits, you see whatever circuit we get, we wanna find the equivalency and just change it to a NAND or a NOR. And that's the reason why we're pushing these bubbles through.
Okay, so do we want to start the demo, Kev?
Yes, sir. All right.
All right. So, well, we have a little summary for you guys. So, it's easy to breadboard. You just gotta do a little bit of practice before you become comfortable with it. Just remember that in the middle of the breadboard, it breaks off, and to the left, we have our own A through E connections horizontally, and we have our own positive and negative terminals going vertically. And on the right side, we have connections from F to J horizontally, and our positive and negative terminals connected vertically. And yeah, now we're gonna just demo you the first part of your lab. So.
By the way, if anyone has any questions at all, just feel free to stop at any time. So is this upside down, Justin, or is it good?
I can't see, dude. It's not real clear. It looks good.
It's good? All
Yeah.
right, so you're gonna get these gates or get these ICs. So they're called integrated circuits. So, or also known as chips. So inside your kit, you got all these chips. So all you gotta do is just read on top, and you're gonna see this the serial number. So over here it's SN74HC00N. So now we just stick this bad boy in here, and we put it in the middle because if we put it on the sides, and we can't access the positive or the ground, so we can't power up this chip. We just put it down in the middle, and
Evan, could you repeat that serial number again?
oh yeah, it's gonna be SN74HC00N.
Thank you.
So when you're looking for your IC chip, you're gonna grab it and you're just gonna read the numbers on that IC chip. So you can disregard all the letters and just put 7400 datasheet and just go to Google Images and it'll pop up for you.
Exactly. And Justin, could you make me host so I could share my screen?
Yeah. Give me 1 second more. Make host. Yes. All right, you're the host, bro.
Oh, share screen, data sheet, and share. So now that we just checked out our what's it called, our IC, so we just type that in and we just go on Google, we go to images. So then after that we check this out, and over here is gonna be the what the inside of it looks like. So Can you guys see how to take the pointer up here? Let's go. No control. Oh, we're good. All right, so you guys see this this NAND gate,
Yeah.
and you see these two inputs, correct? So they're gonna show 13 and 12, and then the output's gonna be at 11. And number 14, you see it says VCC, and then 7 it says ground. So that's how we power up this chip. So we're gonna do that right now. So stop share. So basically, we just went over how to check out what IC you got. So looking at it, you want to power it up. 14 is going to be positive, and 7 is going to be negative. So now this chip's going to be powered up. It's good to go. So the next thing that we want to do is we want to make these connections. We see that 12 and 13 are the inputs. So we'll just stick with yellow wires to make it simple for us as the inputs. And actually, if anyone wants to explain, if it's a NAND gate, what numbers do we want to high or low? So what would get us a 1 in the end?
A high?
Yes. So if you get what's 1 times 0?
0.
And then what happens when you not that?
It becomes a 1.
Exactly. So we want a 1 for one input and a 0 for the other input.
Oh, okay.
Yep. So just right now, we just went over to Morgan's theorem and we actually applied it. So now we're just messing with the inputs. Okay, so now we got our inputs. So now looking at the data sheet, we see that 11 is going to be the output. So basically what we just said right now about 1 times 0 is 0. Then you not that, it's 1. So now this connection is going to be a 1. So now we're giving it a value of 1. And we're going to add this resistor in just because if we do not, we're going to blow up our LED. And yeah, we don't want that. And then ground this bad boy. So, and also looking at this LED, you'll see that one is longer and the other is shorter. So the shorter side is the cathode and the longer side is the anode. Basically what that means is anode is positive, cathode is negative. So with it being negative, the cathode, we want to ground it. And then the positive with the 1. And so now the last thing that we have to do is just put in our power source. So you guys got this in your kit. You guys got the batteries. And then so just positive with positive, negative with negative. And then the LED lights up. So basically that is going to be your first lab. And what we've gone over right now, as Justin just earlier summarized, is we calculated using the Morgan's theorem. And after we calculated using the Morgan's theorem, we actually applied it onto this board. And we looked up the data sheet. We checked out the IC, checked out the serial number, looked it up on Google, and then we created our circuit, and then we demoed. And that is going to be breadboarding, basically all in the gist. Does anyone have any questions? So everyone's going to be studs, huh? About to kill it in the lab.
Hey, Kevin, I got a question.
Yep.
So when you open those IC map things that like show you where the AND gates are,
Yeah.
are you looking at the chip from like the top view or the bottom view?
Dang, okay, that's a really good question. And I forgot to explain that. So let me bring this up for you guys so you guys can see it. So do you see in the data sheet how there's a like kind of like a half circle on like the left or right side, whatever side?
Yeah.
So do you see the half circle on this IC?
It's blurry, bro.
Dang.
Well, I'm holding it so I could see it.
Oh, you're holding it right now?
Yeah.
So you see that, I guess like that little half circle like dent, right?
Yeah.
Yeah, that's how you orient it. So that's how it shows up on the data sheet, right? On Google.
Oh, okay. Okay, cool. Thank you.
Yep. Mm-hmm. Any other questions? Other than that, we just finished lab 1. So yeah, buddy. Anything else you want to talk about, Justin, or no?
No, I think we pretty much covered everything. Just don't forget to put a resistor, because then you'll blow out your LED.
Oh yeah, that happens. That happened to me a lot. So, and you're gonna blow up a lot of LEDs. So that's normal. So don't forget that resistor.
How many ohms is the resistor?
The one that I use is 330. If you guys have a multimeter, you guys could check it that way. I remember we went over on Monday's workshop, and would you be interested in checking out how to check with a multimeter right now?
All right, all right.
So we'll just take a look at this. So over here, what we got, is a multimeter. Dang, this is super close, isn't it? All right, so we got this multimeter right here, and we want to check out the resistance. So what we're gonna do is we're just gonna plug it in. And we're plugging it in, we're gonna turn it on. So positive, so red with red, black with black. And then over here, you can see that this has the ohm symbol. So we click on that. And right now it says overload because it's not connected to anything. And if you think about like the amount of resistance between like your two fingers, it's infinity because there's nothing that will allow it to conduct electricity. So that's why it says overload. And then you grab one end, you grab with the alligator clip, the other. And so it says 328 or 0.328 kilo ohms, which is the equivalent of 328 ohms. So this is a 330 ohm resistor. And also you could just check out the bands, but using a multimeter is easier. So that's how you use a multimeter to check out resistance.
Thank you.
Mm-hmm.
Any other questions?
All right. Well, if there's no questions, you guys are good to go.